Hey, guess what we're doing? I told you at the beginning of the year that we were going to come back and do this one. That's happening right now. So just as a reminder, we're doing transformations. So I give you some sort of parent function shape and you can move it. You can move it left and right, up and down. You can flip it over. You can stretch it out or shrink it down. The only one we haven't done is a horizontal stretch or shrink, and that's because it's backwards from what you'd think, just like half of Algebra 2 is. You know, you know how it goes. So let's get started. So we're at 5C. We're doing transformations of square roots and stuff. So here's a horizontal stretch or shrink, which we also call a compression sometimes, you know. That's going to be inside with the x. So here's my original function. And then my horizontal stretch or shrink will have the function with 1 over b times x just chilling inside. That's my horizontal stretch or shrink. Now b, if b is greater than 1, this is a stretch. And if b is less than 1, it's a shrink. But notice that I put this as 1 over b inside here. So this is actually going to be backwards from what you think, what you look for, okay? So for example, if I had g of x equals f times, or sorry, f of, times is very wrong, 1/2 x, this would be a horizontal stretch of 2. Be a horizontal stretch of 2. I'd be grabbing it on the sides and stretching it out, which would make it fatter. it would make it go like this. But if I said g of x equals f of 2/5 x, let's just show you this one too. This would be a horizontal stretch of 5/2. Okay, I flip it over. But if I had 2x, that would actually be a horizontal shrink of 1/2. Okay. Okay. So that's part 1, is we have unlocked the last transformation type. Part 2 is that I'm going to show you some shapes of these functions. Okay. Now we're not going to be as crazy and as we have been with polynomial graphs, where it's kind of crazy. So let me just show you a few parent functions. Okay. I don't know where I'm going to put those. Put this on a little shelf here. Here's my few parent functions. A cubed, I don't know. F of x equals x cubed does this really cool little S shape. S shape. Man, I can talk, I promise. That S shape goes 0, 0, 1, 1. What else is new, right? But -1, -1. And then 2, 8. And -2, -8. So that's our basic cubic function. Cubic is what I should have said. Sorry if you're following along. I unlocked erasing my pens, so hey. So that was 1, 1, and 2, 8, because 2 cubed is 8. 2 times 2 times 2. And then the negatives of those two. A quartic, which you might remember is x to the power of 4, looks a lot like a quadratic, but it's going to be flat on the middle. So it goes 0, 0, and then 1, 1, and then 2, 16. And so what ends up happening is it kind of goes like a little bit flat right here, just to make up for that big stretch. 1, 1, 2, 16. Notice that we know cubic functions. This is an odd power, so it's down up. Even power, it's the same, right? Different, same, etc. Okay, now here's one that's new. Well, they're all new, but you could have figured those out by yourself. Here's a square root or a radical. The square root of x. So the square root of x is a lot like a quadratic that's been flipped on its side. So it's 0, 0, and then 1, 1, and then 4, 2. But it's not anywhere else. It's just in this little section. 1, 1, 4, 2. So I can take any one of these and I can move them around, right? I can move them left and up. I can flip it over the x-axis. I can flip it over the y-axis. I could stretch it this way. Or now I can stretch it this way too. Let me go get something to help you visualize the difference. I don't have any stretchy fabric that's not black, so I can't even write on that. Okay, but I'm going to show you on the internet instead. So this is Desmos. We love Desmos. We use it all the time. You actually probably hate it by now, but we still use it all the time. So the red one is the square root function. The green one is going to be a vertical stretch, and the blue one's going to be a horizontal stretch. So watch, this is going to be the same amount of stretch, but watch what happens when I go to a stretch of 2. Okay, so the vertically speaking, the green one, I stretched it up by 2, like I doubled every height. And the horizontal version is I basically doubled every length. Actually, I did double every length. So like this was 1 right here, it's 2 right here. This one was 4 right here, it's 8 right here. So everything's twice this long instead of twice this long. Same thing if I go to 3. Right? So they don't look the same at all. That's all I'm saying. So a vertical stretch, the green one, gets higher up. The horizontal stretch, the blue one, gets further this way. It kind of gets shrunk a little bit. Let me show you the same thing, but I'm going to show you it with a horizontal shrink and a vertical stretch. Did I say that right? I might have said that wrong. Because sometimes it sounds like it's the same, right? Because the horizontal gets fatter. So let me show you what that looks like. So at 2, the green one is being compressed vertically. So it's half closer. The blue one is being stretched horizontally. So it's twice as far away from the y-axis. They're not the same. That's a meme template. We are not the same. 3 gets even more noticeable, right? So that's up to times 10 or something. So they get closer to the x-axis, they do, but they're not the same thing. So a vertical stretch and a horizontal shrink are not the same thing. They look kind of the same, but they do different things. So let me just reiterate one more time. The green one is a vertical stretch. It's stretching it this way. Blue one's horizontal stretch. It's going this way. Red is just the main function. Don't worry about it. Okay. Let me see if I can fit an example on this page right here. I totally can. Also, this is also called radical. We're in the radical graphs unit, and that's some stuff just gonna say that. Okay, so let's graph a square root function that hasn't moved. Y equals square root of 1/2 x, and then end the hi miss. What do you say? Hi Machka. You hear that? Those are your adoring fans. And then we'll say, I don't know, +2. So I want to remind you about that +2 part. Okay, so here's my little graph. Boop, 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 boop. So the +2 is an up 2, and the 1/2 is a horizontal stretch of 2. So I'm going to move the 0, 0 up 2. And then, yes, go away. I love you. She's so pretty. So that's my up 2 done. And then I'm going to stretch out, instead of over 1 up 1, I'm going to go over 2 up 1. Okay. And then instead of over 4 up 2, I'm going to go over 8 up 2. Ooh, dang. This looks like a straight line. I hate it. So again, I went over 2 up 1 instead of over 1 up 1, and over 8 up 2 instead of over 4 up 2. We're going to do a lot more of this in class, I promise. Don't worry. And also, you got this. It's the same stuff from Unit 1 and Unit 2 and a little bit in Unit 3, just also with these weird shapes. You can do it. I believe in you. All right. I will see you soon. Okay, bye.